Right. So what you were supposed to do today was you were supposed to start with this reliable reporting task. So that was the first thing you were supposed to do. And you're just trying to show what your current understanding is. It's basically just like a warm-up. So we're going to go over that. And then the why randomized task was basically your notes for the day. And then step 3, that's really what you were going to turn in to the Dropbox. So if you were confused on what was supposed to be due, it's step 3 that I really wanted you to turn in. So we're going to start off with this document. And again, we're just going to work through it. Stop me when you have questions. So it says, a reporter wants to know how people feel about the governor of her state. She decides to ask 100 people their opinions and think of several ways to ask the 100 people. For each method, explain the benefits and drawbacks, then choose the method for selecting 100 people that would best represent the people of the state. So number 1, she's going to go to the capital city, find 100 people interested in politics to respond to the survey. So what would be a benefit to that? What would be a bad thing about that? And this is this part where you can either text in the chat or write in the chat, or you can just speak up. So what would be a benefit for her to go to the capital city and find 100 people interested in politics to respond to the survey? And what would be a drawback? So something like a consequence or kind of like a bias. Thoughts on that? I think probably one of the benefits is that if she has 100 people who are interested in politics, then they're going to have an opinion on the governor, right? So that's a good thing. So all of those people will probably have an opinion on governor, which will make it a little bit easier to kind of get her data. One bad thing, though, is that she's kind of getting biased feedback because these are the people who probably care about politics more, right? Mm-hmm. So that's one downside, is she has a biased group then. Because more likely the people who are hanging around Capital City probably have a similar opinion to everybody else who lives in that capital city, right? Mm-hmm. Just a thought. All right, let's do number 2, and then we can move on. All right.
What's up, Miss Emmons?
What's up, Baron? How you doing?
I'm good. How you doing?
I'm present. I'm here. We're going over stuff. Let me know if you got questions as we're going along, okay? All right, so on number 2, it says, ask the 100 most politically influential people in the state to respond to the survey. So what would be a benefit to that? And then what would be kind of a drawback from that? And again, what's up?
It's only asking politically influential people. Maybe that's bias.
Okay, so it is kind of biased in the sense of politically influential people. So that means that they're going to be well-informed. So they're going to have an opinion, which is good, right? But they're also going to kind of be biased because they might think similarly to other people who are around, you know, or you might fall in like the Republican and Democrat. And, you know, there's more parties than just those two. So just a thought. All right. So that was just kind of your warm up for the day. This was just trying to figure out if you knew what the word bias meant or that kind of stuff, or if you can see the importance of randomizing, because that's really why we're kind of learning this lesson today. So a statistical study begins with a research question, which describes what you want to know clearly and simply. Okay. So they give an example of this, and I'm not going to read this to you. This is basically just a summary of why we randomize our selection of people when we do a study. So just like in those first 2 questions, we said like those people probably are biased. So this isn't really going to give you an overall picture of how people in that state feel about the governor, right? So we want to make sure that we randomize, and there's different ways to randomize so that we can cover a bunch of different types of people. So not examples or examples of assignment processes that are not random would be like assigning students whose names start with A through L to one group and M through Z to the other group. So that's not random. Those are specific people, right? Or assigning students who play a musical instrument to one group and the rest to the other group. So that's putting only people who play an instrument or, you know, the rest of the world. Again, that's segregating them, and that's not going to be a good representation, right? Asking for volunteers. Volunteers, wow, I like marked all over that. Volunteers are not random, okay? People who volunteer are not random. They're going, hey, I'll be involved, right? A volunteer's tribute, okay? So, and again, you don't have to read all of this. I'm just going to give you the summary on this next piece. So understanding different sampling methods. So we take a population and then we pull a sample from that population. This is kind of like saying, okay, all of the students in Gwinnett County, I'm going to look at a sample of students from Gwinnett County, and I'm going to pull one kid from each school, okay? So that would be a sample of the population of students in Gwinnett County, okay? Population is the entire group. Sample is a specific group, okay? So you do need to know, this unit in particular is a lot of vocab, okay? So population is the big group, and sample is what you pull from the population, right? The sampling frame is the actual list of individuals that the sample will be drawn from. Ideally, it should include the entire target population and nobody who is part of that population. So example, you're doing research on working conditions at company X. Your population is all 1,000 employees of the company. Your sampling frame is the company's HR database, which lists the names and contact details of every employee. So basically, sampling frame is just a list of the people who are going to be in your sample, okay? Sample size is really important. If I say, hey, I want to know the overall feelings of students in Gwinnett County, and I only pull 10 students, well, that's not a good sample size to use, okay? You want to use a sufficient sample size in order to represent your population. Normally, the bigger your sample size is, the better it is. But obviously, you won't want to use all 30,000 students in Gwinnett County, right? I don't really know how many students there are in Gwinnett County. I'm just guessing. Okay, so here are the 4 different types. And I think this picture kind of, it demonstrates this a little bit, probably the best. So simple random sampling, that means that, you know, you give everybody, or you write everybody's name in a hat on like a piece of paper and put it in a hat, and then you draw from the hat. That's simple randoming, right? Random sampling. I can talk, I swear. Okay, systematic sampling is everybody gets a number, right? So we number off 1, 2, 3, 4, 5, and I pull certain numbers, right? Or I say every 2 people, I'm going to take that third person, or you know, this right here is doing, I think, every third person. So they go, okay, we're going to start with this person, and then every third person, we're going to take them, okay? So systematic, you've got some type of system, right? Hence the name systematic. Stratified sample is, I like this one because it's a good representation of the entire population. If we were looking at the students at SGHS, and we pulled 1 student from each club and each sport, that would be a stratified sample. So pulling from different clubs, or everybody in that group has the same characteristic, or organizations. Okay, so you pull 1 person from each. Okay, cluster sample is we're going to group people and we're going to sample those groups. Okay, non-probability sampling methods. So this was probability sampling methods. Okay, those were the 4 types that you need to know. And again, this unit in particular has a lot of vocab, and you're gonna have to memorize it. Okay, otherwise you're gonna get lost in all of the words. Non-probability sampling methods. So convenience sampling, this one's really bad. This is just, hey, I'm going to sample the people who are around me. Okay, that's like saying, I'm going to ask you 4 people or 3 people, hey, how do you feel about a certain situation? Would that be a good sample? Absolutely not, because it's not going to give me the overall picture of the entire school, right? Volunteer response sampling, again, that's not random, right? Like volunteering is, hey, I'll do this survey or whatever, and it's not a random probability or not non-probability sampling. I've never really heard of this one before. I don't really see this one that often, but it can happen. You're kind of like asking specific people, hey, can you take this survey? It's kind of like targeting people. Not really a good sampling method either. Snowball sample. It's like if I say, hey, you 3 take this sample. Now go invite 3 more people to take this sample. Okay, that's going to give me a very biased kind of sample because your friends probably think the same way you do. So it's not going to give me a good overall representation. Okay, this was the document that I wanted you to turn in. And so we're going to kind of walk through this one because some people are a little confused on it. So I'm going to start on it. I'm going to make it a little bit bigger so we can actually see. I'm blind. It's fine. Okay. So it says a company offers solar power systems made up of 1 square meter cells arranged into rectangles. They use the designs for their first 100 customers to list the ways people arrange the cells. They are interested in investigating this question: what is the mean area of the rectangles created by our customers? Okay, so what's the average area of the rectangles, right? And area is length times width. Let's keep that in mind. All right, so it says, look quickly at the chart and select 5 rectangles by their numbers. Record the numbers of the rectangles you choose. Okay, so somebody give me a number from this chart.
51.
51. Okay, so I'm going to write 51 down here. All right. Actually, I'm going to circle it. Did this backwards. Okay, I'm going to circle 51. All right, somebody give me another one. Baron, give me a number. 1 through 100, not 51.
24.
24. Love it. Shakira, give me a number. What'd she say? 77. Okay. All right, and I'm going to pick 99. And I need one more. Answer to life is 42, right? Something like that. All right. So it says up here, for each method, find the mean. So the length times width of the rectangles. And I can't read the last little bit. And the sample. Cool. Okay, so for A, we just picked random ones, right? Record the number of rectangles you chose. All right, so all we're going to do is we're going to say, all right, for 51, what was the area for 51? Well, what's length times width for this one? 1, right? Like, I mean, 1 times 1 is 1, right? Okay. So here's the area, and here's the number. Okay. So for 77, let's find the area. Hey, Brock. All right. So for 77, let's find the area. So we're going to do length times width. So how many up is it? 1, 2, 3. So 3 by 1, 2, 3, 4, 5, 6. So 3 times 6 is going to give us 18, right? So that's going to be our area for 77. For 24, we're going to do length times width. So that's going to be 2 and 1, 2, 3, 4, 5. So 5 times 2 is going to give us 10. For 99, I've got 2 by 3. So 2 times 3 is going to give us 6. And what was the last one? 42. So for 42, we've got length times width, which is going to be 1, 2, 3, 4 by 4, which 4 times 4 is 16. Fabulous. All right. Now, on part B, it says select a number between 1 and 95. Use that number and the next 4 numbers for another sample of 5 rectangles. For example, if you select 8, then you would use rectangles 8, 9, 10, 11, and 12. All right, so somebody pick a number.
$11.
11. Okay, so we're going to use 11, and then we're going to use 12, and then we're going to use 13, 14, 15, because they said use the next 4 numbers, right? Okay, and so we're going to find the area of those numbers in this box. Okay, so for 11, it's going to be 1, because length times width is 1, right? For 12, it's going to be 1. For 13, I wish I quit like writing over these numbers. Okay, so for 13, we're going to do 2 times 1, 2, 3, 4. So 2 times 4 is going to give us 8. Hey, Lauren. All right, and then 14, that's going to give us 2 times 1, 2, 3, 4, 5, 6. 2 times 6, yep, 12. And then 15, 2 by 2, which is going to give us 4. Also, this is really difficult for me because I'm old. I'm sorry. Okay, so that's why I keep squinting. It's tiny page. All right, so let's look at C. It says, look closer at the rectangles and choose your favorite, 5 favorite. Record the numbers of the rectangles you chose. Oh my goodness. Okay, so I need 5 favorite numbers. Or choose your 5 favorite pictures, whichever one. And since there's like 5 of us, everybody pick one.
17.
17. Same, man. 17 is my favorite.
I mean, it's only because that's the day I was born. You know?
I feel it. All right, Barack, pick a number, 1 through 100. Or not. Don't pick a number. It's fine. 15. Okay. Let's use some other numbers. Give me 2 more favorite numbers. We can make this go really, really quick.
2.
2 numbers. What's up?
2.
2. Okay. And all right, I'm gonna do 64 and one more number, right? Because we need 5. So what about 60?
About 94.
94. I like it. I'm all about it. All right. So we're gonna record the length times width for each of those. So for 94, we've got 1, 2, 3, 4 by 4. So that's gonna be 16. For 64, we've got 1, 2, 3 by 3, which is going to give us 9. So again, I'm finding area by doing length times width for each of these. 17, that's going to give me 1. 15, that's going to give me 4. 2, that's going to give me 1, right? And then D, it says, without referring to the chart, select 5 random numbers between 1 and 100. Okay, so we're picking 5 random numbers. Okay, so I'm going to just pick, what is it?
16, 35, 100, and I don't know. I don't know after that one. 12.
One more. You said 15?
54.
54. Okay. All right, we're going to find the area of those. So for 100, it's 3 by 3, which is going to give me 9. 16, it's going to give me 3 by 3, which is also 9. And then 35, it's going to be 2 by 1, 2, 3, 4, 5, 6. So that's 12. And then 12 is going to give us 1. 54 is going to be us 2 by 3, which is going to give us 6. All right. So now that we have a hot mess, it says, which method do you think is the best for estimating the mean area for the entire population? Explain your reasoning. Okay, so really quick, what I need you to do is I need you to find the average for each one of these groups. Okay, so find the mean area for each one of these methods. Okay, so what you're going to do is you're going to add those numbers in each one of those blocks and then divide by how many numbers there are. So for instance, in this first box that has the red, I'm going to add all these numbers, 1, 18, 10, 6, and 16, and then divide by 5. And that's going to tell me the mean. So if everybody will take one of these boxes, we can get this done pretty quickly. So I'll take the first one. Who's got the second one?
I'll do the second one.
Okay. Who wants to do the third one? So this is going to be 10.2. And we're finding the mean average for each one of these boxes. All right, so what we come up with for the second and third box? That third box is going to be
6.2.
So,
right?
I'll be taken into custody.
What is it, Darren?
The third box would be 6.2, right? I believe.
I'll take your word for it.
You're never going to let
Second box is 5.2.
people thrive in solitary confinement.
5.2.
Yeah.
All right. So now, which method do you think is the best for estimating the mean area for the entire population? Explain your reasoning. So this is where we're going to actually have a conversation about it. Because really there could be more than one answer on this one, but what do you think is the best estimate for the entire population? So on that first one, what we did was we selected 5 rectangles by their number. So we just said, all right, random numbers. On B, we selected a number between 1 and 95. So they gave us like a subgroup to kind of pull from. And then use that number to get the next 4 numbers. So it's kind of like systematic, right? Like you pick a number and then take the next 4, right? Roughly. Or actually, this one is more snowballing because it's saying, okay, take this, now add the next 4 people on or whatever, right? Kind of could go both ways. C, look closer at the rectangles and choose your 5 favorites. So we're basing it off of just what's your favorite. And then D, without referring to the chart, select 5 random. So this is just randomized. So what do you think is the best way to estimate the mean? Well, A is a little high in compared to all the rest of them, right? And then B is a little low, but that's also because we picked low numbers, right? And then C is kind of in the middle, roughly, but it's more based off of choose your 5 favorite. So it's kind of random, but it could be kind of biased depending on, you know, what your favorite pictures are. And then D is select 5 random numbers. So what do you think is the best way? And it's okay to be wrong because we can have a conversation about it. D is the best way. All right, why?
Oh,
I don't know. What did you come up with?
I was gonna say D, but
Okay, why?
because you're not referring to the chart, you're just picking 5 random.
Exactly. So since it's random, it's going to give us a better overall picture of the entire population versus just that one sample, right? Better representation of population. Look at that awful handwriting. Who let me be a teacher? Okay. And really, A, B, and C are more about being biased, just because it's kind of like A, you're just picking them by their numbers. B, you're picking one that you like and then using the next 4 numbers, which isn't really a good representation. C, you're choosing your 5 favorite. And then D would give us that overall. It could be from anywhere in there, right? Okay, so that's what you're submitting to me. And if you did it a different way, that's fine. In the sense of you use different numbers for these, that's okay. You're going to get different averages if you use different numbers. It's all right. So that's okay. But don't go back and try to fix it. Just make sure that you give a good reasoning for whatever choice you've made down here. Okay? All right. So that's basically what you were supposed to do for your lesson for today. One thing I want to remind y'all of is your performance final is going to be on May 4th. Okay. You're going to pick 2 out of 3 questions to literally like write out and then take pictures of. And I'll send out the instructions more on this a little bit later. And then your final exam, do not miss this day, is going to be May 12th. Okay. Don't miss this day. Write it in the calendar.
Take finals?
Huh?
We still gotta take finals?
Yeah. Yeah. The good thing though is that your teachers made these too. So that's a good thing. Trust me, that's a good thing. But don't miss these 2 days because the final exam is 15% of your grade and the performance final is 5% of your grade. So this is like 20% altogether. So these 2 days, don't miss. Okay? Cool? Because if you do miss this day, then you have to come back later and it's just not fun. So make sure that you handle business on these 2 days.
Bet.
Any other questions?
Nope.
Do we have a test on Friday?
Do you have a test on Friday?
Yeah.
So there's going to be a quiz that comes out tomorrow. Today's Wednesday. Tomorrow at noon. There's going to be a 4-question quiz on AKS 24, which is what you've been working on this week. So the stuff you did yesterday and Monday and then today. So there's 4 questions. It's going to come out tomorrow at noon. And then I'll stay open all day Friday.
Okay. Is it mandatory or?
Yeah, you need to do this one.
Okay.
Yeah.
Okay.
That's a quiz? I'm sorry, is that a quiz?
Yeah, it's just a quiz. Yeah, it's not too terrible.